application சரியில்லை.
Sir, am I audible? Lalit sir?
Yes, madam. You
can
are
we
audible.
begin the session now?
Yeah, we can start, madam.
Yeah, sure. Thank you, sir. So today's session 2 will be delivered by Dr. Lalit Singh, who is scientist in Bhabha Atomic Research Center, Mumbai. The title of his presentation is Research Scope in Nuclear Energy. We welcome you, sir, to the Amity campus with the floral greetings. Please accept our greetings.
Yeah, thank you.
Dr. Lalit Kumar Singh received his PhD degree from Indian Institute of Technology, Banaras Hindu University. He is currently a scientist in NPCIL BARC, Department of Atomic Energy, Government of India for 20 years. And has distinction of working on pressurized heavy water reactors and light water reactors. He has an illustrious career and succeeded in several critical jobs assigned to him in his illustrious career. Through each of them was challenging. His assignments over the year range from design, development, testing, fourth and fifth related research and site validation of the safety critical computer-based system of Indian nuclear power plant. He has published several research papers in journals of high impact factor like IEEE transactions, IEEE computer, ACM, etc. He has been invited for chief guest and keynote speeches, session chair, and talks in many international conferences and short-term courses and workshop and faculty development programs from many IITs, NITs, and other institutes of national importance. He is recipient of many awards like Publication Award, Group Achievement Award, etc. He is reviewer of several SCI Index journals of high impact factor. He is life member of Indian Nuclear Society. He is founder member, industrial coordinator of the proposed Center of Dependability at IIT BHU. He is in the panel of Faculty Assessment Committee for Department of CSE, IIT Roorkee, to assess their research profile and give recommendation. He is the member of editorial board of many reputed journals, guest lead editors of many special issues. He is supervising many PhD students of different IITs, NITs, and PhD thesis, examiner of IITs, NITs, and other reputed institutes. He is an expert member of Industrial Policy Formation of IIT Ropar. He is of many autonomous institutes and member of advisory board of many institutes and universities. He is reviewer and project collaborator of research proposal of Board of Research in Nuclear Sciences. He is also faculty of Nuclear Training Center, Department of Atomic Energy, Government of India. He is interfacing with other countries like Russia, USA, France, etc. for importing nuclear reactors and are based on new technologies. His research interests are in the area of reliability, safety, and security of safety critical computer-based systems. So far, he has completed 33 projects of Department of Atomic Energy, Government of India. We welcome you, sir, for this event.
Yeah, thank you.
Sir, please over to you.
Yeah, thank you, madam, for introduction, and I'd also like to thank to all the organizing committee members who has provided me this opportunity to share some of the experience to all the participants. So to start with, let me share my slides. So are my slides visible?
Yes, sir. These are visible.
And they are changing also?
Yes, sir.
Yeah.
These are.
So I'll be talking on research scope in nuclear energy because we know like nowadays nuclear energy is widely used across the world, and many countries now who were not into the nuclear field, they are also switching in this field because of the economical and it is because it is a green energy. Because of these benefits, as well as there are huge natural resources also in India. So India is leading in this nuclear technology. So we will see like what are the various research scope in nuclear energy, and basically it covers the entire. It is a multidisciplinary domain where you will find there is a scope of almost every engineering and as well as basic sciences and advanced sciences, right? So we will see when we will uh, understand the working principle of nuclear reactor, and then we will see what are their internals and how it works. And I will also demonstrate or I will also keep on telling uh, under which domain what are the various research scope, uh, so that the people can be take it further depending on whichever domain he is. So the if I talk about nuclear reactor, so basically it is a device that is designed to maintain a chain reaction to produce a steady flow of neutrons generated by the fission of heavy nuclei. So what happens? We all know the fission reaction and how it basically originates. So what happens in the nuclear reactor? We know like uranium is having a very heavy nuclei, and heavy nuclei has a tendency to break down or to undergo the spontaneous fission. And when it breaks, it undergo spontaneous fission. It releases some of the radioactive components, as well as it releases 2 to 3 neutrons and some 220 MeV of energy, million electron volt of heat energy. And this is the one fission reaction. Now you can imagine like when I said in every reaction 2 to 3 neutrons gets created, and each neutron will be responsible for creation of one fission reaction. So in one reaction, basically the 2 or 3 neutrons, they are individually they strike to the uranium nucleus and undergo the fission reaction. And every fission reaction they release the 200 million electron volt of energy. So definitely, because so much of energy, I mean, the neutron population keeps on increasing exponentially, and in the similar fashion, the temperature or the heat energy also keeps on increasing exponentially, and hence we have to control this reaction, otherwise it can convert into the nuclear bomb. And why we need to and the other reason that we need to control, because our mechanical equipments that are basically carrying so much of heat has its own limitations, design limitations, like under what temperature conditions those mechanical equipment can be sustained. And hence our nuclear reactor, basically it is designed to maintain this chain reaction so that the steady flow of neutrons can be produced, and which were basically generated by the fission of heavy nuclei. So we can say in other words like it is an apparatus in which heat is produced due to the nuclear fission chain reaction for the generation of the electricity. Okay. Uh, so now let us come to the components of the nuclear reactor, and in this slide we will see what are the basic components and how these components are working in a integrated fashion for the overall goal of power production. So I start with the left hand side of this figure. You are able to see there is a dome shaped structure, and under this there are some components. So there is a one rectangular shaped component having the round corners, and which is known as the uh, reactor core. And basically in this reactor core the fission reaction takes place, where I was talking that so much heat energy gets accumulated, and hence this reactor core has do have the limitation up to what extent it can sustain the temperature. And then the next I told there should be some mechanism we should be able to control the population of the neutrons. So for this, there are the control rods. If you are able to see uh, the stripes of white and red color, and so the red colored stripes are known as control rods, and which are hanged by a metallic string. You can see I have shown a few of the control rods just to understand the concept, and it can vary depending on the size of the reactor or the capacity of the reactor. And so this metallic string is basically hanged or hinged to a mechanical clutch, and which is basically operated by the electronic relays. So whenever so this control rod basically do have a property to eat all the neutrons. So depending on up to what capacity or up to what extent I want to control the neutron population, accordingly I can hang these control rods at the various height levels, right? And that can be controlled by the mechanical clutch, which is basically controlled by the electronic relay, which is being programmed, and it can also give the manual, it can also receive the manual commands. So where the concept of the software comes into the place and the electronics comes into the place, uh, and the mechanical basically these clutch and metallic strings, and the design of the reactor core is all related to the mechanical engineering. So the design should be such that there should not be any wastage of the neutrons, and we should not escape out of this boundary. Otherwise, we may have to lose the neutrons, and will fail to produce the desired level of electricity. And then what happened? Because a lot of heat energy gets accumulated, so there should be some mechanism to transfer this heat energy, so that I need to sustain this reaction, right? So there is a mechanical pipe. You can see this reactor core has the inlet as well as outlet, and so what happened? These inlet and outlet pipe, it basically contains the normal water, and when it passes inside the reactor core, and because its temperature almost like more than 1000 degrees centigrade, and this water becomes at very high temperature, and then it passes through the steam generator. You can see there is an dome shaped structure inside this where the steam is written. This structure
In
is.
psychological, social studies, and HSC.
I request you all of you to please mute themselves so that who want to listen they can listen comfortably. Yeah. So there is a steam generator, and now let us see what a steam generator contains. So it has a logical two segments, and the lower segment basically it contains normal water. And what happens when this hot water uh, uh, goes into this cold water, which is into the steam generator? It becomes very hot, and because of this high temperature, it suddenly converts into the steam. And because steam is of lighter density, so it gets accumulated on the top portion of the steam generator. So you can see like the top logical segment is the steam. And now coming back to this loop, um, after exchanging so much of heat, this water again has to pump back into the reactor core. So there is a pump which is basically pumping back this cool water, and again it because there is a lot of temperature inside the reactor core. Again it takes away the heat from the reactor core, and again it exchanges with the steam generator and produce more steam, and this loop keeps on uh, functioning till the operational period of the nuclear reactor, or till the lifetime of the nuclear reactor. Now coming to the second loop, where I was talking about the steam, what happens to that steam? So you can see there is a outlet at the top of this steam generator, and this steam basically releases, and it connects to the steam turbine, so which basically rotates the steam turbine, and it is.
I think there might be some technical issue.
Yes, sir, you can continue, please.
Hello, am I audible?
Yes, sir, you can continue, please.
Yeah, actually
Audible, sir,
somebody,
audible.
yeah, somebody might have muted me. I don't know who. Okay, so yeah, I have just. So anyway, I was just talking. So what happens to this turbine? So this steam basically drive this turbine, and but not all the steam can be utilized like to drive the turbine. And so the saturated steam is only able to uh, drive the turbine, and non-saturated steam basically it comes down to the condenser, which is also a shape like the steam generator, but of lesser height. And in this condenser, like what is the condensation? So when any hot thing touches the cool surface, it suddenly converts into the water or liquid state. So when this non-saturated steam, so in the condenser, what happens? The cool water basically flows in in the pipe, in the mechanical pipe, which passes through the condenser, and this cool water is taken either by the lake, from the lake, or from the sea, and then it can pumped in into this mechanical pipe. And when this non-saturated steam touches this cool water pipe, it suddenly converts into the liquid, and that water can be again pumped in into the steam generator, and this way a secondary loop will keep on running throughout the operational period of this reactor. And similarly, this is the third loop, or we can say the tertiary loop, which is basically taking the cool water from the ocean, rivers, or lake, and this is basically again it is changing the it is taking out the heat from the non-saturated steam, and it basically converts into and that warm water will be released to the same water source, but we have to maintain the temperature to ensure like all the water bodies the lives of the water bodies can be ensured. So this is the entire working mechanism of the nuclear reactor, and now let us try to uh, look deeply each and every component to explore what could be the research possibilities of under those to design those components or to work on those particular components. Now, first one is a pressure vessel, or the reactor core, which I was talking about. You can see again this figure where the reactor core is written. This is known as a pressure vessel because it has to maintain into the at a higher pressure. Why high pressure? Because otherwise the such a high temperature water can suddenly convert into the steam inside this, and hence uh, to maintain that high temperature water into the liquid state, it needs to be maintained at a high pressure, so it is a pressure vessel. It is also known as a pressure vessel. And depending on the type of the reactor, the geometry of the pressure vessel keeps on changing. For example, if I'm dealing with a pressurized heavy water reactor, there is the concept of tubes. There are the pressure tubes inside this, reactor core, and each tube we have to fill in the fuel in the each tube. While if I'm talking about the light water reactors, it is the concept of the pressure vessel. It is the single geometrical shaped structure, and it is made of usually a robust steel, and that contains the reactor core and moderator and the coolant. Now there are the two things. One is a moderator and one is a coolant. Now, as I said, the neutrons keeps on increasing, and these are the high velocity neutrons basically. And these high velocity neutrons, we need to thermalize these neutrons, because if we will not be able to thermalize these neutrons, it will not be able to hit the uranium nuclei, and we will not be able to get a fission reaction, and hence the moderator is very important to thermalize the neutrons so that it can hit to the nuclear hit the nucleus of the uranium, and it can undergo the chain reaction. Now the second one is the coolant. So coolant is also very important. Let me go back to this slide. So the coolant is nothing but you can see like the inlet and outlet of this reactor core. Basically, this is nothing but it is a pipe, and inside this, depending on the type of the reactor, if we do have the pressure tube type structure, then these pipes may have multiple headers inside this reactor core, and which header is basically in the output and output and input side will be joined. So this will be one output and on one input, or otherwise it is just one pipe can be uh, driven, and basically in this pipe the water which is basically used to transfer the heat energy from the reactor core, and that water is nothing but it is known as the coolant. So now there are a lot of uh, research scope in designing the pressure vessel, because uh, we we get only the efficiency almost 70, 65 to 70%, and to for example, I should be able to design the pressure vessel which can have the longer life. If you see the current scenario, the life of the reactor is probably like maybe 50 years, but the entire world of the nuclear scientists, they are trying to explore to design the pressure vessel so that its life can be, you know, extended to 100 years. Because like when you want to set up the nuclear reactor, you have to uh, invest a heavy money and hence and but the pressure vessel, which is a highly radioactive component, and you cannot replace the pressure vessel because it is a very highly radioactive zone. You can only, once your pressure vessel is life is uh, uh, there is once life is over, you have to just shut down the reactor, and hence the pressure vessel is a main component to decide the life of the nuclear reactors. So there's a lot of scope, like how we can design the pressure vessels so that I can increase the longevity of this life of its life, or so as I said, these could be a series of tubes also, when each of the tube can hold the fuel and conveying the coolant through the surrounding moderator, because moderator is used to thermalize the neutrons. So basically we have to flow the moderator surrounding this fuel where actually the nuclear reaction is taking place. Now coming to the reactor core, this figure is a close visualization of that reactor core which we were discussing. So you can see, and now the control rods, basically these are little at a more upper position. Probably I may not be wanting it to eat up all the neutrons or more number of neutrons. So as I said, the height of the control rods can vary depending on the process status or the process variables in the nuclear reactors. There are thousands and lakhs of process variables, analog process variables or digital process variables. Probably analog process variables may include your temperature, your flow, or the pressure. These are the examples of analog variables. And digital variables may include the status of the mechanical components, for example, valve, heat exchangers like this. And if you look into the structure of this reactor core, you can see this is a moderator, and which are basically vertical stripes having the grid shaped design, and this is a pipe where the moderator is flowing basically, and the solid stripes, vertical stripes, these are the fuel rods where the uranium are basically uh, uranium pellets are there, and the vertical longer, which are at a higher level, is known as the control rod. And you can see the inlet. I have just shown the segment, so the inlet and outlet of this reactor core, from where the coolant is flowing, and to the heat exchanger, which is nothing but the steam generator. And after that, there is a boundary known as pressure vessel. So, and inside the pressure vessel, you need to apply the reflector. Now let us see what is the role of the reflector. So as I said, there are several neutrons which are high energy neutrons and try to escape the boundary of the you know uh, uh, the reactor core. So basically, but there is a moderator which can thermalize the neutrons, but that moderator is not capable to thermalize the neutrons 100%. There could be probability that some of the neutrons still try to escape out of the boundary, and for which this reflector is there, which can reflect back the neutrons which is trying to escape from this boundary. So there is a much scope in designing the reflector. How, what should be the material of the reflector? It can be a coating or it can be a liquid, depending on the for the convenience of the design. And then you can see there is a control shielding, and uh, between the reactor and the pressure vessel, which is basically full of cool gas, so that the temperature, because the inside temperature is very much, and the air, that gas is a insulator of the temperature. It doesn't pass or doesn't flow the temperature to this reactor. So this is known as a control shielding. So as I said, a reactor core basically consists of fuel elements, control rods, and coolant and moderator. And cores generally have the shapes of the right circular cylinders with diameter ranges from 0.5 to 15 meters. Now reflector, we have already talked what is a reflector. It is basically used to reflect back all the neutrons which were trying to escape from the boundary of the pressure vessel, and it is placed around the core to reflect back all the leaking neutrons. So basically, there's a lot of scope to research on the reflector, what kind of materials that can be used as a reflector. Now coming to the fuel, that's the most basic component of the nuclear reactor. As I said, the uranium
करो कंप्लीट करो गड़बड़ी हो जाएगा.
5 is the basic.
Hello.
Yeah, hello.
Dear participants, please turn off your speakers, please.
So
Sir, please you continue.
yeah. So uranium 235 is a basic fuel, and it is usually pellets of uranium oxide that are arranged in the form of tube, and to form the fuel rods. And you can see like there are several fuel rod in one, and in one bundle. So this is one fuel bundle. There the fuel bundle shown here, and the width, diameter of the each fuel rod and the length of each fuel rod will depend on, you know, the overall capacity of your nuclear reactor, and it is also the field of research. uh, what should be the dimension of the fuel, whether you can optimize for more and more effectiveness of the power production. Then again, control rods, as I said, here in this pictorial view, you can see I have shown the control rods into which are hanged at different levels, and which are basically controlled by the control rod drive. And these are the fuel rods, and this is the inlet and outlet where the circulating cooling fluid is going. So it is usually made of cadmium or boron. So definitely it is a scope of research, because earlier cadmium was used, but it has been seen that cadmium brittleness, it becomes brittle very fast, and hence the life of this cadmium is less, and for which people started using boron. And in similar way, like it also have many limitations, so we can strive to research to find out some effective material, like which can be used in the control rod. So its function is to slow down the rate of the reaction to the controllable limit, or otherwise, as I said, the chain reaction blows up like a nuclear bomb. And we can raise or we can lower the control rods, and it can allow operators to control the rate of the nuclear reaction. So it can be, although it can be done manually also, but depending on the process parameters, and depend the control logics can be simulated, or accord, and then as per the control logic, it can be operated by the computer. But definitely I do have a facility to override the control logic and drive it manually. Then coming to the moderator, as I said, moderator is basically to slow down the neutrons from the high velocities,
Sir,
which,
Lalit sir,
yeah.
listen. Participants are dropping the message that they are not able to hear you because your voice is very low. So could you
No,
please increase your volume?
let me check. Let me check.
Could
It
you
is
please
100.
speak
It is
little bit louder?
It is 100%. Madam, you tell me you are able to listen me properly.
Sir, it is very low.
So should I disconnect and restart?
No,
Should
no,
I
no.
try?
You speak little bit louder because your words
Yeah.
are not clear.
Okay. I'll try. Although I'm speaking very loudly, but still I don't know.
Yeah.
So you can tell if I stop uh, presenting and I can restart.
So please speak little bit louder. If it is not audible, then we
Then
will
please let
decide.
me know. Sure, sure, madam. Yeah. So coming to the moderator, so moderator, the function is, as I said, to slow down the neutrons from the high velocities, and hence high energy level which they have on being released from the fission process, so that the probability of the neutron to hit the fuel rods increases. and you can see this figure these the hanged rods are the control rods. Sometimes these are known as neutron catchers also. And the red strips here, it is showing as a fissile uranium which can undergo fission, and the yellow color is known as the moderator, which is the liquid which is in the liquid state. And you can see there is an inlet, so definitely from the inlet the water will flow at the low temperature, and to the outlet it will flow to the higher temperature. Okay, so it's a heat removal process basically. And so the main moderator that are used is normal water or heavy water, graphite, beryllium, and so there is lot of scope to uh, research on the moderators, the type of the moderators that can be effectively used, or that can be used for the effective output of this reactor. So lot of research that is already going on in these areas. And there is an combined, at International Atomic Energy Agency, which basically, uh, which is a nodal agency, and it do have a control of all the nuclear business that are running in all the countries. So basically they elect the scientists, and which are working on these basically different areas. Now the coolant, as I told, it is used to remove the intense heat produced in the reactor, and that heat can be transferred to water in a separate vessel, which is converted into the steam and runs the turbine. And the main coolant that can be used are water, carbon dioxide, mercury, helium. And yes, this is also a subject of research, that what how the more and more effective coolant can be you know created, and or we can be made. So this is the research scope in the area of the coolant. Now containment. uh, so containment, as I said, uh, coming back to that first slide, this dome shaped structure, big structure inside, with all this steam generator, reactor core, pump is there, where the confinement shell is written. Basically, this structure is known as containment, and it is it requires a huge expertise to build the containment, because this is the first barrier where if the it will go, if the radioactive release will be out of the containment, it will release to the public. This will be the first barrier to the first interface to the public, and hence it has to be designed to protect it from outside intrusion, and to protect uh, those outside from the effects of radiation in case of any serious malfunctions inside, because inside the component they can breach. For example, there can be leakage into the steam generator, there can be like a crack into the pressure vessel, or there can be loss of coolant accident. And these are the emergency situations where which can fuel which can fail the fuel because of the high temperature, and the fuel can start melting. And that is the reason we have to uh, design the containment so that it can be sustained under all these emergency conditions. And it is typically a 1 meter thick concrete and steel structure. Why steel structure? Because steel has a good property to reflect the radioactivity, which are the alpha, beta, and gamma radiations. And generally, it does have the two dome shaped structure. One is outer shape and one is inner shaped structure, and both are of almost 1 meter thick, and so that uh, if inner gets failed, the outer will be able to take it up. Now let us see some uh, statistics of the nuclear power plants in India. And India is planning a huge increase in the nuclear power, and it is making nuclear power one of its key policy initiatives, with plans to build a 48 new reactor and boost output, to 63,000 megawatt by 2032, which is almost 14 times increase on the current levels. And the country's existing, there are existing 20 reactors which are generating almost 4,700 megawatts of electrical energy. So if you see this map, India map, almost the nuclear reactor are in uh, all the parts of this India. Uh, for example, you can see the Rajasthan, and Rajasthan is the biggest capacity, having the large number of nuclear reactors, that are uh, 8 nuclear reactors, and one nuclear reactor is of 100 megawatt, one of 200 megawatt, and four nuclear reactors are of 220 megawatt each, and two reactors are of 700 megawatt each, where the 700 megawatt reactors are under construction phase, and rest of the reactors are under operating phase. So you can see which is marked with a red color. Those are in operating phase, and which are marked in the yellow with the yellow bullet, those are under construction, and which are marked with the blue bullet, those are basically proposed nuclear reactors. It means the government of India has already sanctioned, and it is proposed, and all the uh, initial work, groundwork is basically being carried out, at how many nuclear installations or how many units of the reactor needs to put in, and what should be the capacity factor of those reactors, and what are the type of the reactors basically. Similarly, like in the Mahivas Bada, there are four 700 megawatt reactor which are under planning phase. So you can see like it is expanding, the program is expanded across the country, and 48 new reactors basically are under the planning phase. So out of them, some are already under construction. Now you can classify the nuclear reactor based on different parameters. For example, if you want to classify based on the neutron energy, then you can have the fast reactor as well as the thermal reactor. And the fast reactors are those reactors which utilizes the fast neutrons for the chain reaction, and the thermal reactors which utilizes thermalized neutrons for the chain reaction. So if you can see, like in the Kalpakkam, Chennai, the fast breeder reactor is under construction, that is the world's unique reactor in the India, and which is basically designed and developed indigenously by the India itself. And based on the fuel also, we can categorize the nuclear reactor. If your fuel is having the natural fuel, then it is a natural fuel reactor or enriched uranium reactor. Now, based on the moderator used, also you can categorize, for example, water moderator reactor, heavy moderator reactor, heavy water moderator reactor, graphite moderator reactor, beryllium moderator reactor, and on the basis of coolant use, we can categorize the nuclear reactor, for example, water cooled reactor, gas cooled reactor, liquid metal cooled reactor, organic liquid cooled reactor. So these are the classifications of nuclear reactor. Now let us have a look on the pressurized water reactor, which is one of the type. So you can see this is the containment structure, dome shaped structure inside which there is a reactor vessel, and which is having the inlet and outlet, and the inlet there is a cool water which is taking out the heat from the reactor vessel, and this heated water is going through all the way to the steam generator, which creates the steam, and that steam is basically transferred to the turbine to operate the turbine, and pair which is coupled with the generator, and that is connected to the grid, and from the grid it can reach to the consumers, the electricity can reach to the consumers. And you can see the condenser which is having the tertiary circuit. It is taking the cool water from the lake and transferring the warm water. And one more interesting thing, you can see the pressurizer in the containment structure. If your capacity of reactor is very high, then definitely this you have to have the pressurizer to keep on pressurizing, because a lot more volume of this hot water will be flowing in the pipe, which needs to be maintained in some certain pressure, so that the state of that uh, water should not get changed. And this is the boiling water reactor example, and let us see the difference between the two. And the boiling water reactor, it is see the containment structure is only now containing reactor vessel. There was no steam generator like here, and so where the steam gets generated, it gets generated in the reactor vessel itself. So we can a lot of economical savings are there, because we can reduce a lot of piping and instrumentation logics, because this steam is directly transferred to the turbine, and we don't need the steam generator, which is very costly also. But uh, there are a lot of issues in this architecture, and the issues are so first let us see the advantages. As I said, so 50% fewer valves are there, 35% fewer pumps are used, 80% less pipes are used, 45% less seismic building volume, 70% less cables are used, and these are the huge economical savings, as well as the we don't require steam generator. But disadvantages are also many. and there is a possibility of radioactive contamination in the turbine mechanism, because in this, if there is any leakage in this primary circuit, the direct radioactivity can be transferred to the turbine, and which is out of this containment structure. It means the one level security has been breached, and hence we have to take extra safety precautions, which can be turned out very costly, because the safety analyst, reliability analyst, those may be required. And moreover, the wasting of the steam is much in this boiling water reactor, that is resulting of the lower thermal efficiency. So only 3 to 5% by mass can be converted to the steam per pass. Uh, Now this is the control room, and we can see there are several components in the control room. You can see there are so many computer displays, and those may be working on a different platform. For example, some are working on Linux platform, some are working on Windows platform, and hence here the computer scientists are required, which who should have a good amount of knowledge on the operating system concepts. In fact, we cannot use in the embedded systems, we cannot use any third party operating system. So we need to design and develop our own operating system. So because of the safety issue, we cannot rely on the third party vendor. So definitely we need to have an expertise on the operating system. Then second, you can see there are a lot of graphical displays, and how to make these graphical displays. So one thing is you need to expertise in the graphical user interface programming, as well as the design, and how we can basically how we should design so that it can reach a great convenience to the operator, because the operator should be able to understand what actually is happening in the inside the reactor, and in case of any risk, he can take some preventive measures from the computer itself. And then you can see there is a large wall screens. Some of the images we need to show uh, with a wider precision. So definitely here the concept of image processing plays an important role, and you need to have a good understanding the image processing concepts, and accordingly you have to design the system. And because all these systems has to be worked in a coordinated fashion, and hence you should be able to you should be you should have a good expertise in computer networks also. And and you have to write your own compilers, because you cannot rely on the third party compiler. So you have to have a good knowledge on the compiler designs. And then you can see the instrumentation, what how many what should be the size of the panel, what should be the height of the panel, what should be the design of the hand switches, or the various electronic components like hand switches, analog meters, analog displays, digital displays, and biscuit monitors, biscuit PCs, which we see, like for example the things which are not very much important, uh, but definitely it gives a crucial information which in some event analysis is required to be done. And see, you can see in the control panel there are the small biscuit PCs also. So definitely we have to design. There should be the electronics engineers who should be able to design all these electronic components to get best fit into the instrumentation or the control room for the ease of the convenience of the operators. So there are the big electronic panels in which there are several cards, analog cards, digital cards, which are getting the field data from the field, and it is displaying it. It is processing that data in the embedded system, and it is basically displaying to the graphical user interface. So basically, it is a huge network in which it reads the process parameters, it stores those process parameters so that in case of some accident, the same data can be analyzed. So all these are the important factors of the design, and these are the important design considerations for developing any computer-based systems. So because you see, like computer-based systems are the nervous systems of nuclear reactor. So a huge, a good amount of knowledge is required. And you can see a close look on the control panel, wall control panel, where you can see so many biscuit PCs are there, and the graphical user interface, where the graphical trends are running. There are the analog meters, circular meters of different structures. It depends on the convenience to the operator, and the size and shape and location needs to be fixed as per the international practices, for which several standards are available. In fact, the valve, the alarm windows, basically there are that that should have a clear indication. So, and if you see the nuclear power plants in commercial operation or operable, so this is the statistics of the reactor types that are available in different countries, and who are the expertise in that particular country, what are the numbers, what is the capacity of the reactor, total capacity, what kind of fuel basically is being used in that for that particular reactor, what are the coolant and moderator being used. For example, in the pressurized water reactor, the main countries are USA, France, Japan, Russia, China, South Korea, and the total number of reactors are 299 that are under operation, and 283 gigawatt if you sum up the total capacity factor of the nuclear power plant. This much of electrical energy they are producing, and it use the enriched uranium oxide, and the coolant as a water, and moderator as a water. So all these are the statistics of different type of. That's all I wanted to share. And in case of any doubts, I'll be happy to answer.
Hello.
Yeah, hello.
Dear participants, it is open for discussion. You can turn on your speaker and directly interact with the resource person.
Yes, okay, thank you, ma'am. Excuse me, sir. Just I want to know about nuclear reactor is just for the action of producing electricity or for the other purpose as well.
No, it is used for basically primarily it is used to produce the electricity, but every country has a nuclear power program, which the waste product of the nuclear reactor, that is the plutonium, is used to make the nuclear bombs. Also, that is used for the defense of the respective countries. So it has the multi uses, and basically this nuclear energy is being used for the cancer treatment in the in the medical domain. It is used for various other purposes. In fact, for the in the agriculture purposes also, in the waste treatment also. So many like applications are there if you can go through the website, you can find lot of applications of the nuclear energy in Baba Atomic Research Center, which are based on this nuclear technology.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. I'm also another question, sir. Just I want to know that the setup of the nuclear reactor is most common around the population or away from that, so that the harmful effects can be avoided, or there anything we can
Yeah,
understand from
it
that.
is basically at the remote locations where we have very less population is there, because it is a radioactive zone, and definitely the population and basically the you are not allowed for there is some zone for 5 kilometers the uh, population is not allowed, and accordingly, like you have to choose the site also, and the evacuation plan needs to be executed as per the government directives accordingly.
Yes, sir. Yes, sir. Yes, sir. Excuse me. I think uranium 235 is used as the fuel in the nuclear reactor as well. We are seeing from the screen. So any other
Yeah,
material can be used as the nuclear fuel for that purpose.
nuclear fuel we can use uranium, you can use plutonium, you can use thorium with with blanket other actually any nuclei which is heavy, and because the heavy nuclei has a tendency to break, and when it breaks it releases the radioactive activity. So generally these three are the heavy nuclei, and it can be used as the fuel.
Yes, sir. Yes, sir. But that's just most commonly used 235. That is the question.
Yeah, it is not about the best. Actually, depends. For example, the Homi Bhava, he has introduced the three-stage programs, and what he said, because India has a vast resources of thorium, and so when the uranium-based reactors, it releases the plutonium, and that can be used for the second stage reactor, which is already under construction in the Kalpakkam, which is the test reactor. Once the technology gets you know s- uh, uh, proven, then definitely more and more reactor will start coming up, and in the third stage basically that plutonium has to be utilized along with the thorium, and which can also act as a fuel. So basically it depends like on what technology you are comfortable with.
Yes, sir. Yes, sir. Yes, sir. So I think I have one question also. That is the shielding around the nuclear reactor. So what type of shielding that we are using to avoid the harmful of the radioactivity around the surrounding of the nuclear reactor as well?
Shielding in the sense, mostly the steel liners are good, because it has a very good, in fact, if you see the alpha radiation, it you can easily uh, stop with the help of the paper also, but beta particles and gamma radiations, for that, like steel liners are very good reflectors, and which can be used as the reflectors.
Yes, sir. Yes, sir. Okay. Thank you, sir, for this type of good explanation. Thank you, sir. Thank you.
May I ask a question?
Yeah, yeah, please.
Oh, so first
Any
of
other
all,
query?
I would like to thank you, sir, for this very informative talk. I just had a question regarding the nuclear waste that is generated when we are operating this kind of nuclear reactors. So, what kind of policy India is adopting to handle the nuclear waste that are being generated? And are they really safe when we are generating this kind of nuclear waste in large amount? That will be my question. Thank you, sir.
I could not understand your first question.
So
What
I
is your
just
first
asked,
question?
what is the policy that India has adopted in order to overcome or means to dump the nuclear waste that is there? How we are doing
Policy
it?
regarding what? Policy regarding the establishment of the reactor or what?
No, sir. Nuclear waste that is being generated.
Nuclear waste. Nuclear
Yes, sir.
waste, basically we do have the nuclear waste program, and nuclear waste program ensures like because the radioactive element has a half life that ranges from few milliseconds to billion of years. You can see the Hiroshima and Nagasaki, even the effect persists right now also. So we do have a very good treatment for the solid waste, for the liquid waste, and for the gaseous waste. And generally, the solid waste are buried under the ground, and the then liquid waste basically gets we need to evaporate through using the HEPA filters, which can filter out all the radiations and become solid, and then again solid waste can be treated again it can be treated as solid waste. And similarly the gaseous waste can be we can use the set of filters which can ensure like no radiations are going to the public.
Thank you, sir.
Yeah.
Any other participant? If you have any query, you can drop it in the chat box also. Okay. So, Dr. Lalit Singh
Yeah.
has discussed about the research scope in nuclear energy with very minute detail of the functioning of the nuclear reactor, what are the parts, what are the types, everything sir has explained very well. And also explain the possibilities where we can do the research, like what are the system we can introduce to prevent the leakage of radioactive metal into the steam generator, and what can we do for increasing the performance, how can we design the moderator, etc. These are very important points to discuss. And besides, what is the role of computer engineers? What are the type of imaging which we can assess during the nuclear reactor work? So all these things, all these information are very informative. Sir has discussed it very well. Sir has explained every minute detail about the nuclear reactor. I believe the participants were able to enrich their knowledge about the nuclear reactor and its uses as the energy source. Thank you very much, sir, for enlightening us. Thank you very much.
Thank you, madam. Yeah.
Dear participants, there is one information for you. Next session will begin. Next session will begin at 2:30 to 4 o'clock. Please join on the time, and also keep remember that you should not begin the meeting. Meeting will be scheduled by me, and then you have to join that meeting. Thank you very much. Thank you.